Hi everybody, today's lesson is about graphing a cube root function. So let's take a second to remember or learn what is a cube root. Well, we need to know this. So this would be something like the cube root of 8. This notation is saying, that's what the 3 is, the cube root of 8. And you could either do that in your head or by hand or on your calculator. So if you went to math, if you go down to 4, we've got a little cube root action there, and the cube root of 8 is 2. Or you could say, okay, what is the cube root of 64? Well, we could do the same thing, except for I'm going to make it a little quicker. I'm going to hit second enter, and it's going to bring in that last thing that I typed in, and I'm going to change that to 64. And then I'm going to press enter, and I get 4. So now these are good numbers, right? We all know how to count to 2 and 4. So we would say, okay, 8 and 64 are perfect cubes because once we take the cube root, we get a whole number. That's what we're looking for. Because what if I asked you to say, okay, what's the cube root of 19? Well, you're going to need your calculator. Again, I'm going to go to second enter, or you could remember go to math and 4, whatever you think is faster for you. And we're going to find out the cube root of 19. Well, that is approximately 2.668. What if I asked you to graph that? You could approximate. We don't know or could get our pencil exactly where that is. So that would be not fun to graph. And then the last thing is you could see something like 7 to the 1/3. Remember, that's the same as the cube root of 7. So if you see something to the 1/3 like this is the same as 8 to the 1/3, well, we could also do that in our calculator. 8 raised to the 1/3 power. Anytime you do fractions in your calculator, you should use parentheses, especially if you have an older calculator. That gives me 2. Remember, those are just different notations for cube root. So the important thing is, cube root is a cube root. Well, cube root of 8, 2 is the cube root, but the notation is there. Or we've got this 7 to the 1/3 power. That is how we know something is a cube root function that we might graph. So if you look here, I've got the standard formula for a cube root function. A times the cube root of x minus h plus k. Or we could have y equals a, and then this x minus h could be to the 1/3 power plus k. That's the only difference if we change the notation to radical or to exponential. So a is my vertical expansion, hk is my center point. This one is important. H is the horizontal shift and k is the vertical shift. So all these letters actually have a meaning for your reference, but hk is the most important for us here today. So if we look at example 1, it's always important to figure out hk. We need to know where are we starting. Well, this I could rewrite as the cube root of x plus 0 if we want. If it's not there when we're adding or subtracting like we are in our cube root function equation, we know that my center point is 0, 0. So I'm going to start at 0, 0. And I know that no matter what function I'm graphing, I can figure it out by doing an XY table. This isn't just for cube root, but square root or quadratics or anything that you're going to graph, any function, you can use an XY table. So 0, 0 is my center point, which means I need some points on top and on the bottom. So like -1, -2, or 1 and 2. Let's see if these work. So if I put in -2, so if I say, okay, y equals the cube root of -2, well, what happens? So I'm going to go over to my calculator, math 4, and I'm going to take the cube root of -2. Well, I've got negative 1.26 here, so that's not really a good number for me to graph. So remember what we said, that we should make sure we get a nice number. Well, I talked about perfect cubes here. Let's think about numbers that are perfect cubes. Well, 1 is a perfect cube, right? The cube root of negative 1, not 21, oops, is negative 1. So what other number could we put there? Well, if we choose nicely negative 8, we could say, okay, the cube root, of negative 8 is actually negative 2. So y becomes negative 2. And I just did this one in my calculator. It's negative 1. You might be able to find that the cube root of positive 1 is in fact positive 1. And then again, we don't want to choose 2 or 3 or 4 or 5 or 6 because if we take the cube root of 3 or the cube root of 4, we're getting decimals. So we need to find the next number, which happens to be 8, that when we take the cube root of 8, there we go, I get a positive 2. So now all of these points are really easy for me to graph. So I've got negative 8, negative 2. I've got negative 1, negative 1. I've got 0, 0, which we already plotted. I've got 1, 1, and 8, 2. So now this may look weird to you, but if you just go from left to right and go through all the points that we have, we get our function. And this is actually the parent function of what all cube root functions pretty much look like. From here on out, we're just going to manipulate it. We're going to move it up, down, left, right, expand it, and they're all going to have this basic shape. So we can talk about the domain and range. Remember, domain is our x values and range is our y. Well, I see my graph going all the way to the left and could go on forever. Same going all the way to the right. So that means we're hitting all real numbers for the x's. Remember, y's are up and down. So if you keep going down, which this is very, very slowly, as we go all the way to negative infinity, we're going to go down forever. Same with to the right. We're really going up here ever so slightly. And we're going to keep going up forever and ever and ever and ever. So my range is also all real numbers. So let's make some steps here. 1, find and plot the center point. 2, we're going to make x, y table. And then 3, we're going to plot and draw the graph. So this XY table, in this example, I did it by hand, or we have these awesome, amazing calculators. You could use your calculator. So you should know how to do both. And in the next example, I'm going to show you how to speed things up with the calculator. So let's think about step 1. Well, step 1 is to find the center point, HK. So we always look on the inside to find h, or whatever the x portion of this point is. And since it's positive 2 underneath that radical, it is negative 2 in our point, because whatever is underneath there is always opposite. But the one on the outside is still the same, so it is positive 1. So negative 2, 1 is that center point. And here's where things get complicated. Remember that we only want to take the cube root of certain things, right? We don't want any decimals. So if you just take the cube root of, if you say, well, let's make x 3, we've got 3 plus 2 plus 1. Well, the cube root of 3 plus 2 is a decimal. So we have to be very particular in step 2 about our x, y table. Remember, our center point is negative 2, 1, and we need to find others. So this is where it gets helpful to use the calculator. So if you go to y equals and you type in our equation, 3 times the cube root of x plus 2 plus 1, we can go second table and find some values. So I've got negative 2, 1. It looks like negative 3 is going to give me negative 2, and also that negative 1 and 4. Now you could graph with 3 points, but I think it gives you a better shape if you find another one. So I'm going to keep going up till I find a y value that's not a decimal. So here I've got negative 10 and negative 5. And I need to go back into the other direction to find another that's bigger than negative negative 1, but doesn't have a decimal in the y column. So it looks like I've got 6. So 6 and 7. So this takes away some mathematical errors or different things that could go wrong, and it makes it a little faster. So I've got negative 2, 1. I've got negative 3, negative 2, and negative 10, negative 5. Then on the other side, I've got negative 1, 7. Negative 1, 4. And 6, 7. So now again, I go from left to right through the points, and there's my graph. And you can always double check by hitting the graph key to make sure it looks the same, which it does. So that's step 3, right? Plot and graph. And then again, the domain and range are both all real solutions because it goes up and down forever and left and right. And this is always going to be true for a cube root function. So then the last example here, I've got example 3. I still need HK. So this one's a little bit different because it's got this 1/3, but remember that's the same thing as the cube root of x minus 5 minus 2. And you don't necessarily have to write it out, you just have to know that those mean the same thing. So since the 5 is negative, my center point is 5, negative 2. So I'm going to go 5, negative 2. And then the second thing I'm going to do is make an XY table where 5, negative 2 is my middle point. What I would like you to do is fill in this XY table, pause, and do this on your own and make sure that you can check. I know it's on your calculator and not that hard, but I just want to make sure you know those features. So ready, pause, and fill in that table. Alrighty, so your table should look just like mine. Double check that and make sure that you typed it in correctly into your calculator. And then plotting is really easy. So negative 3, negative 4, 4, negative 3, 6, negative 1, and then 13, 0 is something over here. So again, left to right, make that graph, which is step 3. And then lastly, we don't want to forget about the domain and range, which in this case are all real numbers. So now's the time if you need to write down any questions you still have, jot anything down on your notes, rewatch, whatever you need to do to make sure you get this for the next time that we meet. See you then.